Hello? Do you hear me? Okay, let me start. All right. So this is tendon. All right. At the same time, I'm going to give you a simple quiz. So I send to you the link. Okay, but not now. Okay, but we ready the environment. We're ready for the environment. Okay, we're going to give you at the WhatsApp. Okay, you can go to the Telegram. All right. So this is the attendance today. Okay, I share you the attendance. Okay, now we are waiting from others. Okay, the same time I'm going to on my e-learning. Let's we go to my e-learning. Okay, I share with you the notes. Okay, I share you the notes. Okay, for today. We're going to learn the second method. We are going to learn the second method. Okay, and then let's we go to the e-learning. Let's we go to the e-learning. Okay, okay. I share with you the e-learning is about chapter one, the linear system of equation. I already post to you the answer for exercise one. Okay, chapter 1 up to chapter 9 and the formula given during the final exam. Okay. And then for the second week, okay, I already post to you the video synchronized class that we are doing now. Okay. Using WebEx. And then for 25th October, okay, I already sent to you the PDF file, okay, about the fixed point iterative method, bisection method, and fall position method. All right. So we also give you the example for test one, and then the answer script for test one. Okay, you can go, you can scroll down, and then the last, okay, you can go to the test two. Okay, the example of the question for test two. So this is, I think, very helpful. I will upload the video for today class. Okay, so you are at the e-learning. Okay, okay, and then any question. Okay, we not start the quiz now. We are going to finish on the second method before we go to the quiz, right? The quiz is just to make sure that you are in the class. Okay, I'm using YouTube. I think you are very easy to meet me at the YouTube. Okay, especially who are low network. Okay, so now I want to continue my class. Okay, I'm using. Okay, I want to share with you the video. If I can open the video. Okay. Okay. I share with you the video, and then let's we go to the Newton method. Okay, let's we go to the Newton method. Okay. Okay, we already see my okay, we already send you a video. You can see here. We already learn about Newton method. Okay, solving Newton method. Okay, and then we already learned about second method. Okay, second method. This is a second method. Okay, I think we finished already about second method. Okay, if we can, this is a Newton method. Okay, all right. Okay, finish already Newton method. Now let's we go to the second method. If I can share with you the Newton method. Okay, back again. We go to second method. Okay. Okay. Now, what is a second method? Okay, the second method is developed by second line. Okay, Newton method developed by tangent line. So there is many second line for touch or cross the equation of a function of nonlinear system of equation. Yeah, there are so many. So now, okay, I continue here. Okay, I continue here about how to develop the second method. Okay, we learned already. Okay, there are three second method here. Okay, you can see here. Okay, I drag my video to the three second method. Okay, okay, there are three line here. Okay, the first line through S0, the second line of second method through S1, and the third line through S2. Okay, so this is the third second method. So in any form of a straight line go through a 2 point, we can write as a y equal to mx plus c, or y to y naught equal to mx minus x naught, right? So since we have a 2 point, x naught and fx naught, s1 and fx1, fx1, fx naught at the y axis. So okay, if the root is a x star, so the root should be cross the y-axis, meaning that y equal to 0. So we can get 0 minus fx1 equal to fx1 minus fx0 divided by x1 minus x0, x star minus x1. So meaning that, okay, the root is a x star, and then we can replace any grid, for example, x2. So in numerical, okay, I plus 1 converge to the root x star. So this is the iteration manner. This is an iteration style. So issue here, okay, we have to declare another point, okay, to generate the second method. All right. So we assume that xi plus 1 is the next iteration, okay, which is converged to the root. All right. So now how to do that? Okay, we assume that x star now is a all right. Okay, so the next x I plus 1 is equal to x2. x2 equal to x1 minus x1 minus s naught fx1 minus fx naught times fx1. So you see here, I can play around with the formula, the original formula of the second method. So now to perform the iteration, I replace x2 as I plus 1, the new iteration as x2. All right, is equal to xi plus 1 minus, okay, so I try to make the form of second method be simplest, okay, expressed in the simplest form, easy to understand, and so on. So we will get xi plus 2 equal to si, fxi plus 1 minus xi plus 1 fxi divided by fxi plus 1 minus fxi. So you can generate here, you can express in the simple form. All right, so you can do it multiplication only, okay, involve the multiplication only. So the iteration will terminate, okay, in the two conditions. The first, as you know, si plus 1 minus si less than epsilon. The second is fxi plus 2 is less than epsilon. So there are 3 points, okay, you need to know x0, x1, and x2. All right, so you have a 2 point before getting xi plus 2. That is a x1 and x0. All right, so now we want to solve the second method, okay, to get the root for nonlinear system of equation. So let's refer to the example that we learned before on the exponent negative x minus x equal to 0. Right, so we focus on that way. All right, so anyway, you can go to the chat, you can chat with me at the YouTube chat if you have any question. Okay, if you have any question about, okay, we learn now second method. Okay, so let me know. Okay, let me know. Okay, so now you can go to the chat, YouTube, and then you can ask me the question. So now let's go to the example that we learned before, exponent negative x minus x, where x is in the size of interval 0, 1. All right. So now we declare the x0 is a size, the interval. Okay, there are interval between 0 and 1. We put x0 is 0, x1 is 1, and then now we want to find x2. All right, so means that we need to know 2 points at the boundary, at the interval. So we use the second method to generate x2, x3, x4 till all the value x converge to the root. Okay, converge to the root with the specified the condition to control the iteration, to terminate the iteration by two conditions, xi plus 2 minus xi less than epsilon, or fxi plus 2 less than epsilon. F is a function respect to y, so it should be cross the value, cross the y x-axis. So now this is a table that we want to generate. The first is xi, the second table is fxi. We have two conditions. Okay, this is condition number 2, and then this is condition number 1. Okay, now let's go. Okay, let's start. Okay, x2, we use a second method. Second method in your mind now, all right? x0 fx1 minus s1 fx0 divided by fx1 minus fx0, all right? So now we need to insert the value. Use your calculator. Okay, use your calculator to press the value. fx0 is 0. fx1 is an exponent negative 1 minus 1. All right. Okay, 0. And then x1 is 1, fx0 is exponent negative 0 minus 0, right? So fx1 is exponent negative 1 minus 1 minus fx0 is exponent negative 0 minus 0. So the answer is, press your calculator. All right, the second is quite a challenge. Okay, 4 times you need to find the fx1 and f0. So there is a divided function. You will get the answer for x2 is 0.6127. So meaning that, okay, x1, x0, x2 is 0.6127, which is close to the root, right? So now find the fx2 because we want to make sure that fx2 close to epsilon. So the answer is still greater than epsilon, and x2 minus x1, x2 is 0.6127 minus x1, 1 is 0.3 something, which is still greater than epsilon. So continue to x3. x3 is equal to x3 is equal to x1 fx2 minus fx2, okay, fx2 fx1 divided by fx2 minus fx1. So replace the value fx2. fx2 is an exponent negative 0.6127 minus 0.6127, right? So press your calculator. Plus x2 is a 0.6127 times fx1 is an exponent negative 1 minus 1 divided by fx2 is the same value that we get from the previous, okay, step minus fx1, right? So press your calculator. This is important for you to press the calculator to get the answer x3. You get the x3 is a 0.5638. I'm waiting for you, all right, and get the x3 is 5638. You can see that x3 is really converged to the root. The root is 5671. Am I right? So they're close to the root. So this is the second method. Okay, very fast converge compared to the bisection method. Okay, compared to the fixed point method and so on. So you can see here, the second method for fx3 is a 0.005, which is 52, which is greater than epsilon. Epsilon is a 0.0005. So still greater. Continue to x4. You need to continue because x2 minus x1 less than epsilon. Okay, x3 minus x2 is still okay, greater than epsilon. So continue to x4. So they cannot fulfill the requirement to terminate from the second method. So let's we go to the x2 and x4. x4 is equal to x3 fx. Okay, let's we go to the x4. Okay, x4. Okay, we go to x4. Okay, let's we start using the same formula of the second method. Okay. Okay, let's we go. Okay, x4 is x2 fx3 minus x3 fx2 divided by fx3 minus fx2. So since we change the value of x3, so you insert x3 as a 0.5363. So x2 is 0.6127. Okay, exponent negative 0.5638 is fx3. All right, minus 0.535638 times fx2 divided by fx3 minus fx2. All right, so fx2 sometimes you need to repeat again, but you know the answer is similar. You just put in the column to make it more fast. You know the answer because, okay, you press your calculator and then you can get x4 is equal to, okay, press your calculator, 0.5671. Wow, it's really near to the root. All right, so now we go to, we cannot terminate the iteration because x4 minus x3 is greater than epsilon. However, if you go to fx4, which is exponent negative 0.5671 minus 0.5671, the exponential function, the result is 0.000, which is less than epsilon. Your epsilon is a 0.0005. So you terminate the iteration because, okay, the fx is close to the x-axis. It's across the x-axis, all right? So it's close to the 0, all right? So now, too easy for me to correct your answer, you need to transform to the table form. Okay, write in the table form. Why? Because, okay, we can see here, if you can see the table form, okay, it's very simple, okay, it's very simple, and then you can get the answer as, okay, we finish already, we're going to finish, okay, you can see here, the result is, okay, in the table form, okay, the stop iteration because of the fx4 is converged to 0, right? So finish already. This is a second method. So now I want you to share with you, right, the answer, okay? I share with you, I stop sharing, I go to the PDF file, okay, the application, the windows, all right. So I go to the PDF file. Okay, this is the notes about the second method, all right. And then I also send to the e-learning the answer for exercise 1, exercise 1.4, 1.6. Okay, so I give already the answer for chapter 1. Okay, chapter 1, the notes, okay, already stated the e-learning. You can go to the exercise. Okay, there are exercise started from 1.1, okay, about the intermediate value theorem. We go to the exercise 1.1, 1.4, and 1.6. All right. So I want to express, okay, the exercise to your group. Okay, I already get your group. Okay, I'm not sure, okay, you are in the group or not. I stop sharing. I share with you the, okay, the Padlet. Okay, this is your group. Okay, this is your group. I hope, okay, you are in the group. I saw, okay, some of you still not in group. See this one, group limit breakers. Okay, there is three person here. So if you want to make it 4, okay, it's very good. You miss here. So where is others? Okay, I have how many attendance now? Okay, I go to the attendance. Should be 58, but I got here. How many? It's not 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 7, 7, 10, 10, 13. 13 times 4, okay, 13 times 4 is a 52, kan? So it's not enough. So please insert your name in the group because I want you to answer the question, okay, from exercise 1.1 up to 1.6 in the group. I will write here, for example, research red. Okay, wow, red. Why you put red? Okay, I put here. You need to go for the exercise 1.1 number. Okay, you go to the exercise 1.1. Okay, go to the odd number. The odd number I will give to you. Okay, means that what is the odd number? Is number 1. The odd number is 1, 3, 5, 7. So I will add you here, and then if you get the question, okay, what should you do in your group? All right, you need to post. Okay, upload your file. Okay, when you get the answer, you get a photo, take a photo and upload here. Right, upload here. So make sure that you are in the group. Okay, I send to you here. Okay, make sure that you need to upload here. Right, this is very important. Okay, so I will write to you every group for every question. Okay, and then post to you at the Telegram to make sure that you work in group. All right. So if you go to the exercise, it's very simple. Okay, it's very simple. So I make sure, okay, I'm really hope you work in group. Okay, I'm stop sharing your group. Okay, I'm stop sharing your group. Okay. Mm-hmm. This is your group. Okay. Come on. I represent your group again here. Okay. So make sure that you are in the group. Okay. Mm-hmm. And then the question also, I stop sharing. Okay. I go to the PDF file. Okay. Mm-hmm. This is a PDF file. Okay, so all the question at the exercise 1.1. I want to go to Newton method exercise 1.4. You go to exercise 1.4. Where is exercise 1.4? Yes, this is exercise 1.4. I will send to you to solve in group. And then the second method is second method 1.5. Okay, second method at the 1.5. All right. So now I hope you can go to your group, and then I will write the question for every group to try to solve this problem. This is not big problem. Okay, just ask you to find using second method, and then control your iteration based on the 4 decimal places. It means that the epsilon is 0.000005, right? So then the smallest positive root means that you need to find the interval. How to find the interval? Using the intermediate value theorem. All right. Don't worry about the quiz today. It's just as simple as quizzes. All right. So now, okay. Now we go to the. I stop sharing. I want to share with you the another page. Okay. Okay, my quiz. Okay, go to your Telegram. You can click at the Telegram. All right. So I just start the basic one. All right. Okay, I continue. I hope I sharing with you the quizzes. Okay. Uh, you can write the here. Okay, you can click. I send to your WhatsApp. Okay, WhatsApp lah. Okay, YouTube. I send to your YouTube. You click. All right. Okay. Or you can join.com.my. Okay. This is the way how I communicate with you. You can go here, and then you can write the code number. Okay. The code number is 4888580. Right. So I try again. Okay, 488580. Okay, 488580. All right. Okay, I'm waiting for you to join this quiz. Okay, take your handphone. Okay, go to your handphone. Okay, I'm sharing with you now. Okay, Ko Chiong is already in the group. Okay, is already in the quizzes. Okay, and then I'm waiting others. Okay, who is in the quizzes now? Wow, Liu Saifuddin, Wah Wing. All right, Yusuf also in the group of the quiz here. We want to start. Okay, we give you 3 minutes for solving 3 questions. One question, 1 minute or 60 seconds. All right. So not more than that. And then don't terminate, and then you come again if you doing a wrong answer. Okay, we can check you. I'm always monitor through the record. Okay, through the record. So now we have 17 others. I'm waiting others to join me at the quiz. Right. I'm waiting. Okay. Okay, now Chiu here, Chong here, Diva Karan here, now 32 participant here, Eng Ke Jing is here, Lim U Yi is here, Terence Low is already here. All right, Ahmad Osama is here. T Fushin is here. Muhammad Fikri Kamil is here. Okay, Moh Wee Jun is here. All right, El Bara, please come to my room on Wednesday to take your books. Okay, I have an extra book here. You can take it. All right. Rafizat, okay, also here. Please use your own complete name because I'm taking the attendance, okay, through this quiz, right? So you don't need to upload, okay. You just take, okay, plug it. You go to the system or you go to the WhatsApp. I already WhatsApp to you the link, okay, where you can join the quiz today. So there is around how many? 44, 45. Okay, Arun is here. Marsh is here. All right. Okay, thank you very much. Yusuf is here. Okay, Chow, Mo, Pe. Okay, where is our monitor? Okay, where is our monitor? Islam is here. Muaz, okay, is here. Krishnan Rao is here. Okay, how are you, Krishnan? Okay, and then Mahmood is here. Is how many now? 46, all of us. All right. So it's very simple quiz. Don't worry. Okay, you can go to the books. It is an open book. Okay, go to the book. Okay, if you want to take and then who are the winner? The winner who are can answer a question in a short time period. Okay, who are the winner? The winner who are answering the question short time period. So we go to the attendance today. 58. Now you have 57. All right. So who are joining me at the quiz now is a 48. I'm not sure why the attendance is minimum compared to the. Okay, maybe I need to send to you the attendance code. Okay, sorry. I will send, since I'm waiting for you, so I send you the attendance code. Okay. I'm also not have a group. Come on, Muhammad Ilham, try to find your group. And then there is attendance. Okay, I send to your Telegram, to your Telegram. All right. So what happened to you? All right, I'm not sure. Okay, I sent to you already the quiz. Okay, I hope I can send to you already the quiz. You can click to the Telegram. You can get. All right. So now, come on. Okay, can I start the quiz? Please answer as fast as you can. The winner is can answer the question fast as you can. All right. So now, okay, let's restart. Meshwaran, Sai, Deva, Tio, where are you? Rafizat, Osama, Muresh, Krishnan Rao, where are you? Natesh, Calvano, Rolando, Tai, where are you? Muresh, okay, Divakaran, Rafizat, T, where are you? You are still not answering the question. You are not answering the question. Okay. Katie, Rafizat, Diva, Muresh, Sai, where are you? Okay, I think I want to Arun also take very good. Okay, so I want to um, finish. Okay, I want to end the session. Right, so I need to wait. You want to give me time to wait? Okay. Now 27, okay, 27 of you, okay, getting full marks, okay. So, okay, I know who are late, okay, is considered that you are looking for answer from your friend, all right. So, just as, okay, 60 second or 1 minute for one question. All right, so enough for me is enough, okay, and okay, look, who are the winner? Okay, look who are the winner. All right. The winner is okay. March second is Kwa Jinzing, and then the third is a child. This is a student who are getting 100%, means that all the three questions they can answer in the short time period. But the class accuracy is only 71% because some of you not answer the question. And then this is the result. Okay, till you see here. Okay, 27 out of the 47, okay, joining the quiz have a 100% okay result. Thank you very much. Okay, congratulations who are getting the full marks. Okay, who are still okay. You have an opportunity to get okay the good marks after this. Okay, inshallah. All right. So now, okay, I finished already. So I want to share with you. I'm stop sharing. I want to share with you the video. Okay, the video. Okay, let's we go to this video. I'm sharing the fall position method. Let's we continue. All right. So let's we continue to fall position method. I hope you are take your breath. Okay, all okay. It's not the I'm not punish you. I just want to know how many percent of my student okay together with me learning about intermediate value theorem and Newton method. Now let's we go to the second method already finished. Now let's we go to the fall position method. Okay, fall position method. Wait now for a while. Okay. All right. So, okay. All right. So now, okay, I want to continue. There are three numerical methods to solve nonlinear system of equation without condition. We just use iterative method, but there is no specific condition. The last is fall position method. After second method and Newton, now is a fall position method. What is a fall position method? Fall position method, you go to the okay, your YouTube, fall position method, what's that? Is method that we generate the new function respect to the function given in the question. All right. We believe that by using the fall position method, when we draw so many second line, okay, you can see here I'm drawing many second line. So I have many approximation from scene node C1, C2, C3, and C4. So in the first approximation to the root x naught in the interval AB is a C joining 2 points, which is a AFA and BFB. Okay, what's that? I want to go to fix. I don't want to go to fall position method. I want to go to fixed iteration method. Kan? So this is a wrong. Okay, sorry. Let's we go to the another one, fall position method, Newton method, second method. Second method is already finished. Okay, second method is already finished. Right, so let's we go to the PDF file, Newton method. Okay, already finished. Okay, let's we go to this one. It's a fall position method. This one is correct. All right. So many files. Sorry. All right. So let's we go to. Come on. The previous 1 minute. Okay, is wrong. Let's we go to the fall position method. Fall position method. Okay, this one is a fall position method. I want to go to fixed point iterative method. Okay, never mind. I stop sharing. Okay, I go to the PDF file. Stop sharing. I go to the PDF file. Okay, let's we go to the PDF file in the notes 18. Okay, 18. Okay, 20. For position fixed point iterative method. This one, all right, this one is correct. Okay, I think it is the. Okay, if you want to make it small, you can go to the small. But I love if I can go to the view. Okay, the huge view. All right. So I look at my class here. Fixed point iterative method. Yes, it's not fall position method. Okay, I'm sorry. I'm waiting for the fixed point iterative method. What is a fixed point iterative method? So let's restart the class. Yeah. All right. The fixed point iterative method is related to the theorem of intermediate value theorem. Fixed point method, the iteration said that if there is an initial approximation x naught close to the root, right, fulfill the sufficient condition. What is the sufficient condition? The g prime or f prime x is between -1 and 1. To ensure the convergence of the fixed point method, so we assume the new iteration x equal to gx, right? So, but you need to make sure that the gx, which is representing the function of fx, is converged, right? It's a converge. So we declare the fixed point iterative method as a xi plus 1 equal to gx, right? So what is gx? Gx is what? Is about the equation of nonlinear system of equation which is converged to the approximation solution 2. All right. So how to get G? Okay, we are given you exponent negative x minus x. What is G? Okay, any modification function from the question f equal to exponent negative x minus x. All right. So this is the what we are going to express here. We have another equation, xi I plus 1 equal to gx. So now, okay, as usual, when we deal with the iteration, we need to control the iteration as I plus 1 minus xi is less than 0. So issue here, how to get g? Okay, now let's we go to the example. As an example given from the previous iteration, all right, we are using exponent negative x minus x equal to 0, right? So now let's we find many g. Okay, the first g, you equal the function equal to 0, and then you choose x on your right hand side equal to exponent negative x. This is the first g. I already draw this graph using GeoGebra. The graph is a curve. Okay, another g, I can also, from the nonlinear system of equation, exponent negative x minus x equal to 0, I plus x for every both side. All right, so what I get exponent negative x minus x plus x equal to x. Okay, I get both 2x on your right hand side. So now, okay, I arrange again to x equal to exponent x plus x divided by 2 as a g2. My question, which g converge very fast? So to answer this question, you need to know g prime. G prime, okay, is a first derivative of g is equal to negative exponent negative x. G prime for here is a negative exponent negative x plus 1. All right, so you already know what is the first derivative of g1 and g2. Okay, when you insert the value at the interval, okay, 0 and or 1, you will get the answer is between negative 1 and 1. So it shows that both of the equation is converged. You need to check whether g prime x for every x value between the interval 0 and 1 is less than 1 and greater than negative 1. So now we have 2g. Which one converge very fast? All right. So I want to test. Okay. I need to transform to the iteration. I plus 1 equal to G1, I plus 1 equal to G2. All right. So I develop the iteration by guess, okay, by assume the first iteration, okay, is a x not equal to 1. All right. I can also use 0. All right. So now, let's we go. Okay, here, very simple. Okay, I continue. I hope you understand. All right, we continue again because this is only the process of iteration. We already know how to control the iteration. All right, by using the Newton, second, and now is a fixed point iterative method. All right, so you can see here, okay, you can see here, I, okay, 0, 1, 2, 3 for the G1, and I start to 0, 1, 2, 3, 4 for G2. So you can see when you put the value, very simple value, the G that you create by putting X every both part, and then by modify the value of the question, exponent negative X minus X equal to 0. So you can see that the, okay, G2 converge very fast, okay. X6, okay, the G stop because 0.5672 minus 0.5674 is 0.002 is less than epsilon. However, here, okay, you need to go to up to 14 number of iterations. It's too long. It's really take you around, okay, 10 minutes. So try to avoid to find G which is converge very slow, all right, very slow. So you terminate the iteration because x14 minus x13 less than epsilon. You converge, okay, you stop G2 because x5 minus x6 is less than epsilon. So from here, you can get that whatever g you find, the graph should be the g prime, okay, the first derivative of g must be between -1 and 1. All right, so you can find G3, you can find G4, you can find any approximation function which is also converge between 0 and 1. All right, so I find G from here. I try to times x for every both part. All right, so I will get G3, okay, exponent negative x power half. So when I generate the iteration, I saw the result is always 0. So it's not looking converge to the approximation solution. It's 0.5671. It's not. So so G3 is not converge. So you cannot use the G3. Please find another G. All right. Please find another G. All right. So this is a fixed point iterative method where you have another G function which is represent of the F function. All right, so how to do that? Very simple. You need to modify the G based on the existing function. Okay, there are so many choice. You can use G1 or you can use G2 and then you can get the answer. So this one is much faster. So now, let's go to the exercise. Okay, let's go to the exercise. Exercise fixed point, I think 1.5. Okay, second 1.6. Let's go to the 1.6. Okay, this is the way how they converge. Okay, they converge from the x1, x2, x3, x4. Okay, and then you need to make sure that the g prime between -1 and 1 by putting any value in the interval 0, 1. Okay, now let's go to the exercise. Okay, exercise. Okay, I just take example from the book. Okay, you can use your calculator here. All right. Exercise 1.6, they ask you, show that the given equation in the several form of the fixed point iteration. Okay, they ask you to modify, to convert, to transform the x power 4 to x power 3 minus x minus 3 equal to 0 can be represented in many forms, A, B, C, D. All right, so you can do this exercise. I will post this exercise into the group, all right, to the group. And then the second question is, use a fixed point iterative method for 4 decimal places. You have to know what is a 4 decimal places. Epsilon is 0.0005. To control the iteration, not more than 20 iteration. If not, okay, you cannot terminate the fixed point iterative method. So there are so many questions here, but they give you the initial value, the size of interval, and then the modification of G. All right, from the F, they modify to G. So they request you to find what is a root. If we give you the boundary condition, we give you the initial condition, and then we give you the G. All right, the G. So they want to know whether you can get the solution. How to do that? Make sure the G cos x plus x divided by 2 converge. You take the first derivative of G is between -1 and 1. So this is an exercise 1.6. All right. So now, I share with you now, okay, about, okay, the next note. Okay, however, I want to read at the chat what you want to say here. Okay, madam, I changed name to Rafizat. Okay, because I know there is a network problem. And then congratulations, I say to all of you who are getting full marks. Okay, I'm not enough time to type your name and then transform to the YouTube channel. Okay, all right, in the YouTube channel. Okay, there is no question anymore, so I can continue to another topic. All right, so please stop me if you not understand. Ask me to repeat again. Go to the top chat. All right, write your request. All right, write your request. Okay, now, after this, okay, we want to go to the method we call as a bisection method. Okay, bisection method. Okay, let's we continue. Okay, stop sharing. Okay, share to the where I want to choose. I want to go to the next method. Okay, it's a second method is already done. Okay, I want to go to the PDF file again. Okay, it's about the um, bisection method. Okay, bisection. Okay, share with you the notes. Okay, till you uh, can get the answer here. Okay. Okay. Now, I want to find bisection method. Where is a bisection method? I want to find bisection or position method. Alright. Okay, I want to go to bisection method. Okay. Okay, let's we go to the bisection method. Okay, I share with you the PDF file. Okay. You have two strategies. The first strategy without condition. The second strategy is a with condition. With condition, there are two methods, bisection method and fall position method. All right. What is a bisection method and what is the condition? All right. So this is a question for you now. Okay, let's we refer to the initial value theorem that we learned before. Okay, from the initial value theorem, we keep in mind that the root is between A and B, the size of interval, where certified the condition where FA times FB is less than 0. So if we draw the graph, okay, the root is between A and B. FA is a positive, FB is negative. So meaning that the graph cross at x-axis. So we can say that the root is approximate to C. How to get the C? C is between A and B. There are two types to get C. The first is by using okay, bisection. Bisection means that the center between 2 points A and B is A plus B divided by 2. Alright? So for example, the distance between Johor to okay, wait for a while. From Johor to Kuala Lumpur, alright, the center is Pagoh. So A plus B divided by 2 is a Pagoh. So this is the way how to get C. Another way is by using fall position method, alright. So now, what is a condition that you want to fulfill? There are three conditions. The first is FC is equal to 0. Okay, meaning that if C is a root, so FC, the Y should cross the X axis. So the C is a root. Alright. The second if A times FC is less than 0, so we know the value of C. C is between A and B divided by 2. Okay, if FC times FA less than 0, so you change B. You change B as a C. The second condition, if FC times FB less than 0, so you just know the notation, not the value, the notation, the negative. If negative FC FB, okay, is negative, so change A to C. change A to C. So this is the three conditions that you need to consider. So what is mean? Means that you have a size of interval A and B. So you need to close A to the approximation C or close B to the approximation C. So means that your size of interval become smaller, smaller, smaller and close to the root. So that's we call as a bisection. By moving A and B, okay, the size of interval, the interval to C. All right, so with this condition, okay, since we are working in the iterative, we need to put I. I is a number of iteration or a grid or a node. All right. So FCI should be less than epsilon. This is how to control the iteration. Fxi minus xi is less than epsilon. So this is a common, okay, this is a common way how to stop the iteration. For example, okay, for example here, okay, before that, I want to see, okay, what happened to you? There is any question? Okay, I asking you any question? All right, any question? All right, so I'm looking for any question till now. Okay, okay, now we continue by applying the bisection method as for solving the problem nonlinear system of equation to find a root. All right, so we know already there are three steps. The first step is, okay, find C. The second step is find whether C is replaced as B or A will replace as C. So we want to know where C allocate, whether at B or at A. All right, so replace the position of A and B. All right, so this is very important, means that the size of interval will be always changed to converge to the root. All right, so now, since I have a question here, I need to find what is A naught and B naught. I develop the table like this. Okay, I need to develop the table AI, BI, CI, FAI, FBI, just a notation. But FCI we need to write. Okay, FCI you need to write the number. Okay, C you need to write the value. But FAI and FBI you just want to know the notation, whether positive or negative. All right. So now, okay, if B times C is negative, so you choose the second formula. You need to change A as C. If FA times FC is negative, all right, so FA times FC is negative, go to the first formula. You need to change B. So this formula, don't forget, because we want to make sure that whether B change or A change by C. All right. So now let's restart. Okay. We know the function is exponent negative x minus x. All keep in mind. Okay. FA, okay, A is between 0 and 1, you put, and C is a 0.5 because 1 plus 0 divided by 2 is 0.5. Exponent, okay, FA is an exponent 0. Exponent 0 is a positive. Exponent negative 1 minus 1 is a negative. This one is a positive. FA is this one. A is exponent negative 0 minus 0 is a positive. Positive. Okay, what bisection? You go to the bisection method. You can press your calculator to get the value of F1. Okay, F1 is a 1, and then FB is a negative 0.632, and then this one is FC. FC is an exponent negative 0.5 minus 0.5 is a positive 0.107. So you need to find the value negative. All the formula, you need to find the value negative. So negative is FB times FC. When you have FB times FC negative, change A to C. Okay, so I change A to C. C is 0.5. So I continue again to get C. C for second iteration is 0.1, 0.5 plus 1 divided by 2 is 0.75. Very simple to get C. It's a center between 2 points. And then I get FA. FA is always positive. F0 is always positive. FB is a 1 here. Okay. FA is a 0.5 is a positive. We get from FC. FB is always negative. And then let's we find FC. FC is a exponent negative 0.75 minus 0.75 is negative 0.278. All right. So now to get a negative value, it should be FA times FC. Okay, go to the formula. If FA times FC less than 0, so change B. So now let's we go to the next step, change B. Change B. All right, the next step, find C. C is A plus B divided by 2 is 0.625. Get the FC. Okay, FC is an exponent negative 0.625 minus 0.625 is negative 0.09. To get negative, it should be FA times FC. It's a negative. So the next step, you need to change B. Okay, change B to 0.625. Okay, to C. And then get the C. C is A plus B divided by 2, 0.6563. And then get the F, F3, Fx3 is an exponent negative 0.563 minus 0.563 is a positive 0.66, 0.006. All right, so now how to contribute to negative? It should be FB times FC is less than 0. So which interval we need to change is A we need to change. So you can see here, okay, this is between 0 and 1. All right, change the next step, change A to 0.5. The next step, change B to 0.75. The next step, change B to 0.625. The next step, change A to 0.563. All right, so what we do is the size of interval always change, all right, till we have the condition where, okay, we have two conditions, number 1 and number 2. All right, so in here, you can see FC is 0.567. Okay, X6 is 0.571. If you minus is greater than epsilon. However, we stop the iteration because X7 is 0.00, okay, which is less than epsilon. So in the bisection method, okay, there are two conditions. Which one comes first? It's not just 0.67 minus 0.61, which is 0.00, how much here? 0.11, 0.004 is also converged. But the first we want to look is FC7 is less than epsilon. This one we terminate the iteration. Okay, you can also terminate by minus 0.567 minus 0.571, okay, which is near also less than epsilon is one of the reasons why we terminate the iteration. All right, so we said that, okay, the iteration does not terminate, okay, because at 7 minus at 6 is less, the iteration is terminate because at 7 minus at 6 is less than epsilon. All right, so let's we terminate together. We get the root of the nonlinear system of equation is 0. The last one is 0.567. So this is your answer. So we need to terminate together. We need to terminate together. All right. So now, okay, let's we go to your your YouTube. Any question? I'm waiting. Any question? All right, ma'am. I don't understand. Please repeat. All right. So okay. I repeat again. Okay, what you learn now is a two-way to solve nonlinear system equation. We done already the first strategy without what? Without condition, right? We learn Newton method, okay, secant method, and fixed point iterative method. All right, that is focused on the iteration manner. So the next is, okay, we solve the second strategy by using the condition. Please remember, there is a 3 condition. You stop the iteration for bisection method and fall position method with 3 conditions. The first is FC, okay, is less than epsilon. The second is FA times FC less than 0. So you change B as C. If FB times FC is less than epsilon, you change A as C. That's all. All right. So I just give you 3 conditions solving the nonlinear system of equation, okay, based on the bisection method and fall position method. Yes, the first part you are quite confused because which one you want to change, A or B, by referring to formula. All right, two formula. All right, FA times FC is less than 0. Change the new interval for B. And then FB times FC is less than epsilon and less than 0. So change A as a new interval by replacing A to C. So that's all. All right. So I know this is new for you. After this, you will get used this formula. All right. So the last is let's continue. Okay. The last is a fall position method. Okay, what is a fall position method? Okay, I stop sharing. Okay, I stop sharing. I go to the right. I go to the fall position method. Right. I hope I share with you the fall position method. What is a fall position method? Fall position method is the solution, okay, with the condition, okay, involving iteration to solve nonlinear system of equation. All right, the condition same as the bisection method. However, in fall position method, to get C, they are using second line. All right. In the bisection method, you are using C is equal to A plus B divided by 2. Very simple. But in the fall position method, they are different. Okay, you need to go through using the second method, using the second line. Right. So now we have so many second line here. There are 3 second line here. Okay, you can get to get X star. You can get let's I make it bigger. All right, I think it's much more bigger now. Okay, so to get the what is the value of C, how to get the very good C, it's not like bisection, very simple, A plus B divided by 2. Now you want to get a good C. To get a good C is a formula based on the second line. Okay, you go to the second line in the fall position method. Okay, what you have the first approximation, okay, where we call as X star between A and B, and then the point of C is joining to point is if you have a straight point AFA and BFB. Where is AFA? AFA and BFB. You have 2 points here, okay, with a different sign. The straight line L line is you know already in the fall position method, y minus y1 equal to mx minus x1. So we go to the tangent, okay, the gradient, fb minus fa divided by b minus a, x minus b, y minus fb. This is the way how we replace, okay, how to replace 2 point go through 1 line. All right, so this is a common formula. Okay, you still remember y minus y1 equal to mx minus x1. It's common. All right, so since there is a linear, okay, there is a line cross the x-axis. So at C0, okay, you have to know 0 y or f c is equal to 0 to make sure that there is a root. So you can replace here y is equal to 0, fb plus fb minus fa divided by b minus a, c minus b. So we want to put c on your right hand side because c is a root. C is a between a and b. C is a convergent value. So C is equal to, you modify this equation. Very simple. B minus A divided by FB minus FA. Alright. So you just modify the equation times, okay, times FB. Alright. So in the simplest way, alright, you can make it more simple. Okay, expression you can get C equal to AFB, just times, okay, just time, okay, from the divided here, just time A times FB minus BFA divided by FB minus FA. This is how to get C. It's not easy because we are using the second or the 2 point go through the linear system of non-linear equation. Right. So this is a way how to replace C by using the bisection method. Okay. So now, we continue again bisection method and fold position method. Okay. All right. So we know already the value of C. C is equal to A naught FB naught minus FB naught FA naught divided by FB naught minus FA naught. So for the second iteration, you need to create C1. Okay, you need to create C1. Right? It's a A1 FB1 minus FB1 FA1 divided by FB1 minus FA1. So this is a C, right? So that's you are doing. And then second is you need to close the size of interval by applying two condition. Okay, don't forget the condition. All right, so we need to create all the C. We need to do the iterative all the C started from C0, C1, C2, C3, C4 until C converge to the approximation solution. Okay, at the X star. All right. So come on, we can make sure that the iteration will be stopped with the two rule. The first is FCI less than epsilon, or xi minus 1 minus xi is less than epsilon, or ci plus 1 minus ci is less than epsilon. Which one come first? Which one come first? So this is very important. All right, to make sure that we can terminate the iteration at the same number of iteration. Okay, now let's we go to the example. Okay, we go to the example. We are still solving the nonlinear system of equation exponent negative x minus x. We still, and then we want to control the iteration by using epsilon 0.005. All right, we are using 3 decimal places. So use your calculator. Most fix 3. All right. And then the first step, okay, we want to find the C. Second, we want to apply the condition. There are two conditions, whether FA times FC less than 0 or FB times FC is less than 0. So we need to remember all these conditions, keep in mind, because we want to use it for make sure that the interval will be changed, whether A and C or B, C and B, all right? A is a left corner, B is a right corner. So whether A and C or C and B. So it depends on if FA less than times FC less than 0, change B. If FC times FB less than 0, change A. All right. So control the iteration with the two conditions I told you, FCI less than 0 or CI plus 1 minus CI is less than 0. So which one come first? Okay, which one come first? All right, so now we develop the fold position method. Okay, we develop the fold position method table. Okay, make sure that the table is really okay, depending on AI, BI, FCI, FBI, C, and FCI. So the important is we want the notation FAI, FBI, the value of CI, and the value of FCI. Okay, as usual, to start the iteration, we start with the A not equal to 0, B not equal to 1. All right, so you need to find what is the value of C. All right, what is the value of C? What is the notation of A? FA is exponent negative 0 minus 0 is equal to 1, and FB is exponent negative 1 minus 1 is equal to berapa? We can get from the second method before is a negative 0.632. Okay, negative 0.632. So you know the notation, one is a positive, one is negative. So that fulfill the condition of the initial value theorem. C naught is a formula that we learned before, is A naught FB naught minus B naught FA naught divided by FB naught minus FA naught. So just replace the value of FB naught. Okay, FB naught you know already is a negative 0.632. Okay, FA naught is 1. Okay, N naught is 0 and B naught is 1. So replace, okay, you can get the new C, which is not easy to get C as bisection. Bisection is very easy. A plus B divided by 2, but it's not here. So the value, the center between A and B is okay, let's press your calculator. Okay, use the function, okay, to make it more faster. You can get FC0 equal to negative 0.071. All right, negative 0.071. So you put here, the value is negative. All right, the value is negative. FA is a positive, FB is negative. So you need to find negative value, which is FA times FC is negative. Okay, if FA times FC is negative, you need to follow the condition number 1. Okay, the condition number 1. So because FA is a positive, FC is negative. All right, so you put here FB is negative, here negative, put negative. FC, C is already done, 0.613. FCI is negative, so you use condition number 1. All right, where FAI times FCI is a negative. So which you need to change? B you need to change as C. So change B, we are waiting to change B as 0.613. All right, 0.613. All right, now the next step, find C1. C1 also using the same formula of the fall position method. All right, so FC is a, you can find FC1 is a A1 FB1 minus B1 FA1 divided by FB1 minus FA1. Right, so this is a FC1. All right, so the formula is given in the fall position method, and then when you insert, what you get is a negative 0.008. It's also negative. So you can see here, FA positive, FC is negative here, so still fulfill the condition number 1, where you need to change B. You need to change B. You change B to FC1. FC1, you need to go to the formula. FC1 is negative 0. C1 is a positive 0.572. All right, so now you're lucky because why? FC2, okay, if you get this FC1, okay, FC1 is less than epsilon. Wow, you are lucky. You can stop, you can terminate the iteration, you are happy. I'm also happy. We terminate together at the iteration number 2. All right, FC1, okay, you put exponent negative 0.008 minus 0.008 is 0.00, okay, 0, which is less than epsilon. All right, so the next, okay, since you have 0, so we go to the answer. The answer is a C2. Okay, the answer is C2. What is a C2? Okay, let's go. It's a 5. Okay, we move faster. 0.567. 0.567. Right? So C2, very easy. You just apply this formula to get C2. So eliminate the iteration. Right? Because FC2 is 0.0000. So this is a condition where we can eliminate from the fall position method. So from here, you can see that, okay, bisection is the worst. Number of iteration for bisection method to complete the iteration is, you go to the bisection method, how many? Go to the book, is a 7 number of iteration. However, when we apply for position method, okay, the iteration stop at the number of iteration 2. Alright, so it means that the computational cost for bisection method is too complex, okay, too many. The cost is too high compared to the fault position method. Okay, they just compute at the 2 number of iteration. The runtime also for position method finished at the small number of iterations. So from here we can see that number of iteration of bisection for position method is lower than bisection method. The computational cost for fault position method is lower than bisection method. Okay, the runtime for fault position method is very fast compared to bisection method. So we can say that the fault position method is a good and alternative numerical method for solving the nonlinear system equation with condition. Okay, with condition. All right, never mind. I know, okay, this is new for you, but we have a textbook. Please buy the textbook, okay, because all the way, how the step, all in the books. It's very simple and easy to understand. Okay, any question? Okay, come on. I'm asking you any question. There is no question here. This is about our quizzes. Okay, the new question. All right. So I'm waiting for the new question. Okay. Any question? Okay. We end the chapter 1. However, I love if I can share with you the exercise. Okay, I share with you now the exercise in PDF file. Okay, you can go to the PDF file. Okay, go to the chapter 1. Okay, you go to 1.2 bisection method. Okay, bisection method. 1.1, 1.2 exercise. Okay, see here. This is exercise bisection method. The question is simple. They ask you to find the root using bisection method. The first thing you need to know is what? Find A and B. How to find A and B? FA is a positive, FB is negative or opposite. Alright, so you need to find A and B. Okay, this given already between 1 and 2. And then use the C. C is a 1 plus 2 divided by 2. It's a very simple. However, for the fault position method, it's not simplest like bisection method to find B, to find C. Alright, so now this one also, they ask you to find the bisection method, to find the root between 0 and 1, and then start the iteration with the 0 or 1. You can use GeoGebra to get the graph x minus 2 power negative x. Okay, you can go to the GeoGebra, right, to get the how to draw the graph to guess the answer. Okay, I think many times I'm already show you the GeoGebra. Okay, let's I share with you the GeoGebra. Okay, I share with you the GeoGebra. All right. Okay, here. Stop sharing. Share with you Google. Okay, go to the GeoGebra. Right. So click here. Okay, this is the GeoGebra. You click GeoGebra Classic. No need to download and so on. Right. So you go to the question. Okay, the question requests us. Let's say I'm using exercise 1.2 number 2. X minus 2 power negative x. Okay, x minus 2 power negative x. Okay, 2 power negative x. Okay, let's we see. There is I make it more bigger. Okay, there is a root between 0.5 and 1. Okay, there is a root here. Right, there is a root here. So if you want to solve this question, you have to notice that it's between 0 and 1. So since you know already, so to answer this question, okay, I share with you again. Okay, since I know the answer is between 0 and 1, so I share. Stop sharing. Okay, I go to the PDF file. Okay, I want to answer question number 1.2, x minus 2 power negative x, which is between 0.5 and 1. So I start the iteration from 1 because it's close to 1. Okay, I start the iteration close to 1. So I start as not as 1. I not start from 0 because the root is very far from 0. So this is the way, okay, to solve this problem. You can use GeoGebra or you can use start from 0. Okay, however, you contribute to huge number of iteration. All right, sometimes I give you a question, what is the S naught? Okay, so thank you very much. Okay, we are now at the last, part of our class. Okay, we already finished um, chapter. Okay, I share with you the PDF file again. Okay, where we finish? We finish already exercise 1.2. Okay, 1.3 is about the four position method. You also finished there. Newton method is already finished. 1.4. 1.5 second method. Okay, this is the enhancement from Newton method. It's more accurate. All right. So the last, the second method. The last is a fixed point iterative method where we need to fulfill the condition of the G prime. The exercise at the 1.6. Okay, so I'm going to distribute the exercise to your group through the Padlet, and then you try to solve this problem. Submit before next week is 1st November. Yeah, submit all the exercise that I post to you through Padlet. Okay, you submit and then solve the problem in group. All right, not individual. If you have a problem, you have a friend to ask. All right. Okay. Any question? I'm looking for any question of you. Okay. Any question? I'm looking the chat. Go to the chat. Okay. Go to the chat. Go to the chat. Okay, ask me a question. No question? Wow. No question so far. Go. No question. Izaldin. Wow, you are very, very good. Okay, you can answer. Okay, you can understand. Okay, the process of iteration, the process to find a root for solving non-linear system of equation. Right? So if you have no question, I end this streaming. I end the broadcast. Okay, so I'm waiting for you. Okay, before I close the session. Okay, bye bye.